Hey everybody, hope you had a great weekend. Good job last week kicking off distance learning. Today we're going to start working with putting rational numbers on a number line. Last week you started with integers on a number line, which are whole numbers, and today we're going to get into rational numbers, which are fractions and decimals, and putting them on a number line. So for today's lesson, we're going to start off in the book. We are on lesson 3.2, rational numbers on a number line. And we will be on pages 149 to 154. So if you don't have your book and a pencil, please hit pause and go get those things right now. Okay, so to start us off, we got to think of our number line from last week. We know that in the middle is the origin, or 0. And as we go to the right or up, it's going to be positive. And if we go to the left or down, it's going to be negative. Today's intro problem says plot negative 3/4 on the number line. So we need to put down negative 3/4. Well, integers are whole numbers like -1 and 1. Rational numbers, which we're learning about now, are going to be fractions. So since I don't see a fractions, we need to make one. So I see that we need to go negative. So I'm only going to worry about the bottom right now. And it's going to be in fourths. So I'm going to mark off equal fourths. So as I'm looking down, I have the negative or 0, then negative, 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 4 equal spaces. So it'll be negative 1/4, 2/4, 3/4, 4/4, which would be 1 whole. So if we need to mark down negative 3/4, I would go down to 1, 2, and here is negative 3/4. So on our next page, page 150, let's get into rational numbers a little bit more. A rational number is a number that can be made into a fraction. So the definition we have is any number that can be written as a quotient, which means to divide, of two integers is called a rational number. A rational number can be written in the form a over b, which is a fraction, or negative a over b, which is also just a negative fraction, where a and b are integers and b cannot be 0. So what that basically means is you can't have 2 over 0 or negative 3 over 0 because you just can't divide anything by 0. So it's non-existent. So it has to be a real fraction, positive or negative, to be a whole number. It says find in position negative 4/3 on the number line. So 4/3, that's telling me that we are going to be dealing with thirds. So between 0 and 1 and -1 and -2, we need to have them broken down into thirds. So I'm going to divide them into thirds. 1, 2, 3, 1, 2. So we have 1, 2, 3. So now that we've done that or have that established, let's do that again. So we have our steps and we're going to break them down into thirds. Negative 4/3 would mean that I would need to go 1/3 negative, negative 2/3, negative 3/3, which is 1, and negative 4/3. So I'm going to mark my negative 4/3. So now let's do our second problem, which says let's do negative 1/2 or negative 5/10. So negative 1 and 5/10 is between negative 1 and negative 2. So I know that 5/10 is a half. So I'm going to make a spot halfway between negative 1 and negative 2. But theoretically, since it's 5/10, which really means 5/10, we need 10 spots. So I would 1, 2, 3, 4, 1, 2, 3, 4. So between -1 and -2, I have 10 equal spots. The fifth one down, which is still a half, would get there. So I have -1 and 5/10. All right, now we're on page 151. Starting off with number 1, it says, why are decimals rational numbers? Well, decimals are rational numbers because decimals can be written as fractions. And as we learned on the vocab part, all fractions can become rational numbers. So if we have -1 and 5/10 as an example, and we want to make that a fraction, we know that 5/10 is a half, so it'll be negative 1 1/2. Or if we're doing improper fractions, I would have negative 3/2. They are both equivalent. Number 2, why are integers rational numbers? Well, all integers are rational numbers because integers can also be written as fractions. So if I have number 1, that is an equivalent to something like 3/3, which is a fraction. Or if I have the number 2, that is equivalent to 8/4, also a fraction. So that's why integers can be rational numbers. And number 3 says, in another way on the previous page, why does the point plotted at negative 1.5 instead of negative 2.5? Well, the problem told us to do negative 1.5. So we put it between negative 1 and negative 2. So it was between them. If it was between negative 2 and negative 3, then it would be 2.5. But because it was between negative 1 and negative 2, that's where negative 1 and 5/10 happen to go. Number 4, we need to write the number positioned on each point. So point A, B, and C. So let's look at our number line. So between 0 and 1, I see we have 1, 2, 3, 4 spots, 4 equal spaces. So that means our denominator is going to be fourths. So if I'm looking for A on number 4, A is 1, 2 to the left of 0. So that means if we're dealing with fourths and it's to the left, it's negative 2/4. Or that would be negative 1/2. B. Let's erase a little bit and clean up what we got up here. So B is 1, 2, 3 to the right of 0. So if we're still dealing with fourths, it would be 3/4. I'll hit pause, or why don't you hit pause, and please go ahead and do number 6, which is letter C. So please figure out what fraction or rational number letter C is. Okay, so we know it's going to be negative because it's to the left of 0. And it's going to be a fraction that ends with 4, or 4 is the denominator. So I see it's between negative 1 and negative 2. So my whole number is going to be negative 1 and 1, 2, 3/4. Negative 1 and 3/4. 7 says plot a point P at negative 1 and 1/4. So I'm going to clean up on top here a little bit. So it's negative 1, which is right here. And we need to go 1/4 to the left of that. So 1/4 more. There is my letter P. Down below, we have write the number positioned at each point. So we're going to do 8, 9, 10 together, and then you'll hit pause and go ahead and do 11, 12, 13. So number 8, A. Well, first let's look at our number line. I'm going to look between 0 and negative 1. Because there's no numbers there, I know I'm not going to mess anything up. So I see that there's 1, 2, 3 tick marks, which makes it 1, 2, 3, 4 equal spaces. So we are dealing with fourths again. So letter A is right here between negative 3 and negative 4. So I know negative 3 is going to be my whole number, and it is 1/4, or 1 space, and we're dealing with fourths, to the left of it. So negative 3 and 1/4. B is between negative 4 and negative 5. So I know my whole number is going to be negative 4, and it's going to be negative 4 and 1/4, 2/4. So negative 4 and 2/4, which we can reduce to negative 4 and 1/2. Both of those would be great answers. And then C looks like it's to the right of a 0, so it's going to be positive. So it's between 1 and 2, so more than 1 but less than 2. So 1's going to be my whole number, and it is 1 space, or 1/4 to the right of 1, so 1 and 1/4. So go ahead and hit pause right now, please, and then do D, E, and F. Okay, letter D is between -5 and -6, and it's 1, 2, 3. So it's -5 and 3/4. E. Here's E. I'm going to clean up again a little bit. E is right here. So it's between 0 and 1. So more than 0, less than 1. And it is 1, 2 spaces. So that means 2/4. 1/4, 2/4. And letter F is between -2 and -3. So I know it's going to be past -2, but not quite to -3. So it's between -2 and 1/4, 2/4. -2 and 2/4, which we know we can reduce to -2 and 1/2. 14 says plot -6.3 on the number line below. So 6.3 means 6 3/10. So I'm looking at this number line, there's 10 spaces, so I need to go 1/10, 2/10, 3/10. So -6 3/10. Oh, a little too big. Let me redo that. So it'll be 1, 2, 3/10. And number 15. So we need to draw a number line that represents the denominator 5. So we are -7/5. I know that's going to be a negative, so I'm going to start with a 0 here. And then let's go -1 and -2. So I know that -7/5 is the equivalent of -1 and 2/5. Because if I have 7/5, that is 2/5 plus 5. So we got 7/5 7/5. So this right here would equal 1, and I'd be left with 2/5. So I need to break each spot into fifths. So that'd be 1, 2, 3, 4. So I have 1, 2, 3, 4, 5 spaces. That means 4 lines. So if I want to go to -1 and 2/5, I would find -1 and -2, and I would go 1, 2. -1 and 2/5. Perfect. Great job. That's plenty for today. So we're going to stop right there with our book. So please go ahead to the next section, and let's hit our vocab up. All right, for our next vocab word, we have rational number. I took a screenshot of rational number in mathisfun.com, so you can definitely use that for reference, or use the definitions in your book on page 150. So we have rational number. It's a number that can be made into a fraction. That's my definition. So examples, I could do 1.5 because that's a fraction. And let's do a -1 also, so I'm going to do -4/3. Great examples. Non-examples, well, we learned that we can't have something with 0, so let's go 4/0. And also, you cannot have pi. Pi is not a rational number because it's irrational, which means it never ends. So if we have a never-ending number like pi, it can't be one spot on a number line, so it's irrational. Characteristics can make a fraction. Another one I'm going to say can be positive or negative. All right, and if you want to add a characteristic, feel free. So please go ahead and do your own examples. Take a picture or a screenshot of your slide and add it to your vocab keynote. All right, great job, gang. So we got our nice intro to lesson 3.2, understanding rational numbers. So great job getting going. We got our book done. So now go ahead, go to Schoology, reread the update to see what's next to do. And if you have any questions, please let me know. Go to Questions for Instructor, email me, or come see me at 2 o'clock. Keep up the great work, gang. See you soon.